Okay, so for my current layout, I ended up right now with 9 lights. I think we can just make it 10 if there's a little naked spot here. In order to check how this is affecting our layout, so if I go scatter, if I turn on scatter and preview, you can see that they are kind of in between. And then overall, I put a little bit of a transform to pull everything up a little bit, because I do want the bottom of this layout to be darker, to give the sense of depth to it. So if I put back this city LookDev, bring in my terrain. Next thing, I think we can work on the terrain as well, just so we can give it a bit of a something that is not gray. Which then again we can probably use the 3-planar setup. So in order to test this as good as possible, I'm going to go to the systems and enable material override, and I'm gonna hit render. Let's remove the fog as well. So it's gonna show us everything. One other thing that I'll probably show you is the bundles. I actually don't know if Redshift supports bundles, but I believe it does. So we can go, there's a bundle list. So we can select all our lights. And not this bundle. And we can create this little icon here and then add our lights. So this creates a bundle. So we can call this city lights. So instead of overpopulating our 4 slides section here, we can define the bundle. Actually, this is please enter. Oh, we could, I didn't know we could do that as well. So let's do it like that. Let's remove this bundle to see if it does the same thing. Let's go back to Redshift, objects mode, and then let's call this city lights. And I'm gonna create a bundle. And let's call the city light and accept pattern, or accept bundle, I guess. Accept bundle. And now this is updated as city lights, which means it's also created here, which means it's a bit easier to manage. What do you want to be on and off, or like if you do a mouse over, I think it should give us some information. I guess we can read them through the documentation, because you can like turn on, turn off lights a lot easier like this. Like read through this documentation. This is quite useful. I use the bundles. You can also do smart bundles, which are a bit more smart, obviously, that can use some naming conventions. And you can do the same thing for objects as well. It's easier to manage. So now I have my light bundle, and then my LookDev camera is on. I did my override for this. The only missing thing is my volume at the moment, but let's see how this looks once we hit render. Should give us a. So this is my current lighting. The only problem I have with this is that I think we still have too much light at the bottom. And then obviously I think we're a bit too colorful. So that's why I want to go to each of my lights, and I think desaturate their colors a little bit. So let's desaturate this guy. So we need to do it for all, unfortunately, one by one. Not necessarily one by one. I think it is probably a good time to show a super cool feature that I use exactly for this problem, to manipulate information, but on a table. That's called the parameter spreadsheet. So I have 9 lights, and I want to decrease the saturation of each one of them, but I don't know if this saturation will actually accessible. We could try, because the color, and it creates a new value from saturation. I can show you how to change the colors, but because it's a color node, and the saturation won't work. But at least while we are at it, I'm gonna show you. So if you ever have to change settings of a lot of things, what you can do is you can create an parameter spreadsheet network, the interface, and then just drag and drop an operator to here, okay? And then drag and drop an attribute here in here, okay? So you got the light color G, light color B, but now it's only using city lights 01. So if I to put an asterisk here, now it gives me the value of all the lights. This way I can change this information a lot easier. But they all look to be green and blue. Well, that's correct. And this is a really easy way to change a lot of attributes in one go. But like I said, we were a bit too colorful, so let's just desaturate a lot of colors here. And there's a green. This is a bit desaturate as well. U2. I think those reds and blues are overwhelming. I think we need an orange too, to be honest. This is blue. Let's make this this is blue, so let's change the color to blue so we know what we're looking at. This just helps for organization. One of the red ones, I did change the colors after, just had to rebalance the way they were showing up, so it just a better distribution of different colors. Okay, let's just keep desaturating these. Come here a little bit more. I think this guy as well. This one. I don't have red. How come? I don't have red anymore. I broke the colors. This was supposed to be, this one is green. This was green. No, this is orangish. Okay, it doesn't matter. Let's do another render. We can always play. I'm not gonna spend so much time with the colors, but it's, again, that's just an artistic choice. The volume is gonna get the bottom of the everything is blue. I think we broke the colors with the when we were playing with the attributes editor. Okay, well, now it's all same, and I don't want all same, so let's just maybe look at the area lights itself. Color changes, so let's go this one. I want a bit orange, a bit on the hot side, a little bit desaturated. Okay, let's give this an orange color. Okay, we're gonna redo this again. This one can stay like that. This one can stay like that. Where are these? These are too close to each other. Okay, so let's change the color of this one to a bit more green. So let's give it a greenish color. This one, let's make it red, desaturated red. A little bit on the orange side also, I guess. Okay, this one is red ish. It's more like this. This one, we don't have a green. This one is, what is this color? This one is blue. Let's leave it blue. It's far from the other guys. Let's give this an orange as well, in like a full orange. Okay, let's do another render. Okay, it's a bit more interesting now. I think we are, right now we are lacking I think a strong red, like a red, yeah, I guess in the center we can have a bit of a red. So this guy, so this light, whatever this light is, let's find this one and just give it a pure red, maybe even something strong. Let's make this red, and let's increase its intensity multiplier. Let's do one last render. Hopefully we're gonna be happy with it. Okay. So what I want is that, like I said, I want the bottom parts to be a bit darker. So I am going to move my lights up more. Maybe 100 units. So another render. Oops. It doesn't really get darker, but it kind of helps the tops to bleed a bit better. So because we have the light passing through the tops, and I think it feels a bit more, it almost feels like a fake GI. Okay, now I'm going to turn on my volume, and we will then start with playing each light's contribution scale. So we did discuss on how to make a volume before. So let's turn this guy on. Okay, and then we're gonna go into our out network, find our city render node, and then bring back our fog object in and out again, hit render. Obviously it's going to affect the render speed. But it's definitely going to give us a nice sense of depth, atmospheric haze, even in this frame, in these buckets. If we start comparing, we get some nice fall off in certain areas, so we want to see the floor. Let's see, I think that's gonna tell us a bit more of the story. That's like, yeah, that's what we want. We don't want to see the bottom of it. It's like, because it's dirty, polluted, it's a sci-fi city. Okay, let's wait for it to cook, render fully. Hopefully Houdini 18 is coming with a new renderer. Things are looking bright. Supposed to be a lot faster. They do want to catch up. I mean, Mantra is already a very good renderer, but it kind of lagged behind on other renders in terms of speed. It is a production renderer. It does support a lot of features that other renderers support. We occasionally use it in actual movies, like I don't know, you name it, like Godzilla, X-Men, a lot of movies, pretty much. Like, and especially where it comes strong is the volume and the particle renders and the water shader, etc. These are really good. So, but again, its speed was the problem, one of the major problems it was, and then now I believe it's coming back on track. Sci-Fi has been putting a lot of resources on other sections of Houdini than effects. So now, like, the rigging works really good, the crowd rigs work really good, which we will create our a simplified traffic system that is using crowd. And so hopefully we'll soon have a fast renderer as well, because one of the really strong things about using the Mantra's own renderer is that you're inside this network, and everything you can do in an attribute warp is pretty much there, available to you, so you're already comfortable with it. All right, so in gray shading, this is actually looking really interesting. The volume is really helping a lot. I think the amount and the density is pretty good as well. Now let's turn off our override and let's render our city with the current baked textures. And so this one took 2 minutes 28. So not so bad for a nice big gray city. Now I'm gonna hit render to end place. It's gonna load our textures. I did bake another set of textures. I have been optimizing certain values in between all these videos just to get a bit better sense of the better speed. So obviously at the end of this video I'm going to just go back and give you those numbers again. But if you have super good video cards, you can, or just time, just bake the highest possible resolution that you can afford. I am going to rebake these textures 2K as soon as I can. Again, these are using 512, but I don't think that's going to be enough for the close-ups. More the better, obviously. It's just going to look much better. Okay, so let's wait for the first bucket to come off, then I can pause the video and wait for the rest of the render to come off for us to check the performance. This is a full HD render. My monitor is 4K, so it's actually a reasonable size, a reasonable resolution. And I don't have global illumination on. Yes, I just have some high settings for reflection. And some high sampling settings, which I think we can drop a little bit. But let's wait for the first bucket maybe. Well, ideally I don't want to go over 10 minutes per frame or 15 minutes per frame. Even in Redshift rows, these are a bit slow, but these are not single shampoo renders or some product replacement renders, so they do take time. So I'm gonna stop this and just maybe decrease those values a little bit. These are quite low. Ideally, I think 4, 4, 8 will probably. Okay, I'm gonna stop this, and then I'm gonna disable this optimization and then drop these sampling values to, I don't know, 0/32. I think for beginners that should already speed up the renders. I don't think there's anything else I can do. I disabled the tessellation displacement. I'm not using them anyway. In case I accidentally turn on or something, and this is gonna be a very big problem in this scene, trying to displace everything. So it's off. It's just a habit. Okay, let's hit render again. And I'm gonna now stop the video, and then we're going to move forward with the crowd system. Okay, so 4 minutes 47 seconds. It's a pretty good render. There's some noisy areas, obviously, but these are only 512 pixel textures. So, but then 512 by 4, so that's 2 by, I think it was 2 by 3. We can load some of the textures here just to see. But still, nevertheless, this is a good number. If I go under text buildings, I did also start using a versioning for my textures and automated numbers, resolution numbers, just for easy visibility. So by that I mean, if I select the Redshift now, instead of outputting just writing here 512, I'm just copying it from here. So you just right click, copy. So that just kind of tells me the size of the texture, resolution of texture. And then if I go to output, here it is where you paste it. Right click, paste relative. And before I didn't have the versions, but then I realized that it's probably better if you have a version 2, so it kind of goes in the correct place, which means that obviously you need to update it everywhere else. Otherwise it's not gonna work. These I left out because I want to be able to choose what I want to load, not just directly connected to the Redshift render node. And it also means that I did the same thing. Come here. I did the same thing. This is not correct. I did the same thing for the output version 2, which means now I have version for the output proxies. Okay, so now before, I guess I can close this, I suppose. Yeah. Before we start creating our fake traffic, I think we can organize this network a little bit better, since it's getting slightly bigger slowly. So these are our lights. I suppose that's gonna fit somewhere here quite well, because these are our test cameras. So they are gonna be fine here, and I guess these. Okay, here, let's put this on the network. Let's call it city generic lights, maybe. City generic lights. If you want to add a bit more complexity to it, Redshift lights support textures, so we can plug in some textures so they're not just shooting bright white lights. The other thing that could be more interesting is that if we could actually, where are my advertisements? These advertisements here, we could use advertisements to be lights as well, but then because that like this, because without us turning on global illumination, our emissive lights are not going to contribute to our emissive textures are not going to contribute to the volume, only these lights with the contribution. So I believe it would be quite more interesting if we actually create an area light per advertisement and then get the proper values for each based on the like instancing, like what we do here. But then that's definitely gonna slow us down like quite a lot, and then we could like that would be really nice because we can get the proper light bleeding of the text of the billboards into the volume. That would make the scene so much richer, but that's all up to your system pretty much. Okay, so and this is going to be a part of our render node already, so I guess this can go down because we're going to squeeze in a lot of other things in between. Okay, let's align it nicely, and we can call this render nodes. Give it a different color. Okay, so let's start with the traffic. In order for us to create a traffic, we need some assets. So let's create a geometry node. Let's call it cars. And I did have a lot of cars that I did before. They were like quite low res cards, etc. So what I'm gonna do now is I'm going to copy paste this from my other scene, and then we'll have to update the paths. And that's because I want to show you how much I had to prepare them before I could actually use them. So I'm gonna copy this network down here, and then I need to copy these my original models from my original scene, which means they should be all under models obj cars fbx. They were coming from my scene. Where is it? Sci-Fi chase geo models obj. So I'm gonna copy this into our tutorial geo, which is obviously what you will end up downloading without these ones, but these ones are like I'm supplying the certain models, but the terrain and city walls and ads we're gonna create together. So I'm gonna remove those once you are downloading it, because that's what you need to create. Where do we go from here? Okay, now it should be loading fine. So if I hide everything else, auto is on. If I connect, so I did make some quite this is the one that we see ship breaking through. They're quite low res. Obviously, if you wanna improve those, you're welcome. These were just created like just pulling a few vertices up and down just to create a little variation. This one was a police car So this one had a bit more polygons, but they don't have interiors. So what I had to do to prepare these models for proper rendering is, for example, we can start with the bus. I actually had to hand select these guys because I lost that information from Maya, and then you just hand select the primitives, hit tab, go just to say ID glass, and then select these guys, ID lights, and everything else is ID metal, and I kind of missed those sections, I suppose, a few more. And then I just kind of create the normal. I did create UVs in case I need it for whatever reason. I should have actually used the UV layout as well under this, because they are small, so they would have taken a lot faster to actually lay it out, to do it properly, to have proper UVs in case you want to bake it anyway. And then this is not doing anything, so I didn't do anything there. Then I sent some materials which are in cars shaders, which are here, shader network. I just created those based on those three groups: glass, metal, emissive. And so I did assign, I did orient everything on Z axis, Z plus, and then I packed it, and then I had to create a subnetwork for the agents, because it's kind of accepting a character rig. This is the only way I could make it work. But I was following basically what the shelf tool for the crowd was doing, and they did have the object coming in from a geometry subnetwork. It's because I think that's related to the rigging. I'm not entirely even sure why, but it ended up working. As soon as I get that, I have created an agent. I call it agent 2. Current layer default, collision layer collision, and then these are my pretty much the clip name is Volk. I guess this is what we can do. Other names which can be adjusted as well. So this one is agent 1, agent 2, agent 3, vice versa. And then finally I create them as size attributes. If I go here, and the size is the size X. So get box gets you the well, basically, if I do the math here, get box size 0, so size 0 is 5 on X, and then get Z, right? So that's, if we bring in something to draw, it's basic math. It's just that let's go here. Okay, so that's our bounding box. So basically A, B, right? A times B gives you the area, right? And then I'm getting the square root of this. Why was I getting the square root? I'm not sure. This is returning me 11. I shouldn't have, actually I shouldn't get the square root, but I did. Size, why this is the proper size. Not the square root of it, but let's keep it. I did record that for a while ago. Maybe that was after the simulations I did get the values. Anyway, so then I merge all of these into this merge node. So I have like 8 packed objects with each with an agent name and a size value. And then I did stash them. We don't have to, but let's stash it. It's just that so I don't want it to calculate every time I run this, right? So basically you can just cache it out here. This was doing just multiplying the sizes for testing, I suppose. There is no other thing here. That's pretty much it. agent clip offset ST car sub. Yep, there is no other note here. I'm not sure if this could be performance related, but like I said, it's gonna be very it's gonna be like a pop related crowd. So you can replace all this, but in the end, whatever you want to add as traffic, that's what you need: an agent name, a position, size as well. As for resting the size, we will use that for, because I'll explain you when we do the distribution. And I think in the name attribute as well, and it will need to be packed objects, just like a rigid body simulation. So that's what we need for cars. Then we need roads, imaginary roads at least. In order to create our imaginary roads, we need to create our roads, obviously. So that's gonna start with, let's say, let's zoom out. So we need to find out certain sections where we can automatically create roads. So let's call it geometry. Let's say roads, I guess. Let's dive inside. Okay, I need to object merge my buildings from scatter. Oh, we didn't, did we not create the bounding boxes for this? We should have. We should have created our bounding box. We could have used those. So let's bring in these instances instead. This is gonna be a problem, but we can try. Because I want to get like a closed version of these. If I VDB these, I think it's gonna work. Maybe no, because it has a lot of open areas. We can try. Let's try. If it doesn't work, we'll create a bounding box versions of all these. So it's gonna be like a very proxy version. Let's, while we are here, let's give this a bit name so it's not left like that. Out display. So what I want is the same thing from here, but hopefully outbound, outbounds, yeah, outbound, out low poly, out low poly. Okay, so right now we're displaying this. We object merged it into our road network. So that's where it's gonna tell us if it's gonna work or not. Let's bring in the landscape as well. So another object merge. And this time we're gonna bring in the terrain. So just gonna pin this in and go to my terrain network here. And I have my, I think this one was, yeah, this guy can go here. So that's my environment. We should probably, while we are at it, create a low-res version of this for, this is actually not that heavy anyway. I should do the trick, that's fine. For simulations, but it's not that heavy, and if we need it, we'll create it on the fly. Okay, let's go back to the roads. Now I want to extrude volume, because I want to create a volume out of this. So disable, let it cook for a second. Okay, and then VDB from polygons. Since this is a big object, I think you can put a 5. Oops, that's the wrong place. It's gonna create a VDB surface out of it, that's fine. And then we're gonna do the same for the building, but this may not work because we need open geometry, we need closed geometry, and that means that we may have to just create, yes. No, but this is packed, so unpack. Yeah, that's gonna be heavy. Yes, we should not do that. Let's try. it will try to unpack everything. It's still 180 objects. I think this should, if there's only one level of packing, the VDB should work, as far as I remember. But this is quite too heavy. I think we should really go back and then create our low poly closed geometry collision shapes, so we can use them for simulations as well. But let's see how this will work. I mean, if this works, it's going to be more accurate, which is pretty cool. But it is taking time. And this is going to be quite big for our memory usage as well. Cooking. Well, I mean, yeah, that will do the trick. Okay, maybe we just wait. That's fine. Okay, let's combine these now. VDB combine. And we're going to change that to STF union. Left, right, they have the same resolution. It's gonna merge like that. That's cool. And now what I want to do is to inflate those a little bit. So VDB reshape. I'm gonna delete it by 4 voxels. So it's just gonna get a little bit fat. Well, a bit too much fat, but it's the main purpose of this is that because we're gonna use the negative space for roads, pretty much. Okay, so now let's create a grid. And I think that should just cover our landscape area, like where we want to build the road. So it's slightly smaller than this shape. So if we make it bigger, that should do. And just give it like 500 rows. Okay, and I think we can push it a little bit inside as well. Okay, so something like that should do. Now we're gonna create a group, SOP, and group whatever is inside this by the volume, because we have the volume here. So then we can go points to delete and select by bounding regions, bounding volume. So it selected all these sections, and then we're gonna blast that group. So it's gonna give us like a negative space that where we can maybe use something for creating a road network or something simple. And how do we do that? I'm gonna show now. So let's create a group SOP. Oh, we got out. So basically that's where there's no building and there's no land is, if you can see here. So let's dive back inside the roads, create a group SOP again. This time call it start PT and name it also same. Change the settings to points, and this is not the one, sorry, it needs to be the group range. Before it was a part of the group SOP, now it's split, so it's a bit confusing. So start PT is for start points, same name, and then you're gonna change the group type to points, and let's give it a number like 4,000, and it just gives like this many out of 4,000. So if you go, it's kind of like selecting, but then as you can see, we want to randomize that, so we should probably put in a random sort, put a sort SOP just before we select the go. So if you can see now, it says select 7 out of 4,000, but then it's just all lined up, and we want to randomize that. So you go to point sort point and just random it, and that's just going to select random points. And now it's a bit too much. Let's go back to 1. So it gives us, I don't know how many start points. If I do middle mouse, it gives us 21 start points. And then let's copy paste it again. Let's call it end PT. And this time it's the same, but we're gonna offset everything, some random value. And now drop in a find shortest path. and we want this to start from start PT and end by end PT, and from each start to each end, and that's gonna give us some network, which is pretty cool. Now it actually does a bit more than that. It creates a lot of overlapping networks as well, so we want to like make sure that it's not using, I guess we can do the triangulate. Okay, so just to avoid these zigzags, I think we should probably divide and that should give us some more straight lines, but then we are lacking the opposite ones. So can the divide do that? It cannot. I guess we can use a remesh SOP just to create a bit more organic. You know what? We're gonna let Fuse to handle that. Okay, so let's drop in a Fuse SOP. And it's gonna be a wide distance, which is 10. So it kind of generates us a bit more interesting networks now. And what we can do next is to make sure maybe we smooth those out a little bit. So we can apply, it was the blur attribute blur. Let me try this one first. I'm just trying to get some soft shapes pretty much. Connectivity, proximity, no, connectivity. It's not kind of doing it. Give me smooth edges. Now. Okay. Well, yeah, kind of working. Okay, we can leave it as it is. Maybe pin border points. Oh, okay. But we want to pin the border points because that's actually a pretty cool effect. All right, just found out something. It's really cool. But this is gonna make our cars collide with the building, so we don't want that. We just wanna smooth out certain sections. And if I do that, that still doesn't soften as much as I'd like to, because it has more. Okay, that's probably all right. So like that, we have a lot more. Okay, so I'm not gonna use Fuse. I'm gonna use the Fuse after, so it gets rid of some more problematic areas. Maybe let's see actually if it does any good. Points 958. Yes, it does kind of like merge everything, which is cool. So we have a clean network. I guess this could be like little switch junctions. This is gonna be a mess with the for the cars, but I guess if you want to increase that, yeah, nah, that actually works fine. So since this is only one layer, I want to put a copy SOP. Well, maybe the other thing is that I want to put this further down at the bottom. So where this should be where we want our lowest traffic lane is. So let's bring that a bit further down. Maybe minus, no, this is 0. 0 is up. Okay, minus 100. Okay, so let's say we don't want any traffic deeper than that. Actually, we do want something deeper than that. Probably less cars. 150, and that's at the bottom. Okay, and the road network at this automatically. We are getting a bit soft in certain sections there. Okay, we don't want to get too close to the edges anyway. What we can do next is actually I have a better idea. Let's bring it all the way up. Let's put it 0. Okay, so we want something higher too. Probably where's our buildings? Yes. Let's bring it maybe 50, even 100. That's gonna generate a lot of traffic. Okay, so that's the top layer. That's fine. Actually, we should probably run that in a loop to generate different traffic structures, because originally I was just creating one layer and then copying it, but I think think we can make something a bit more elaborate. So let's do that actually. Where's our buildings? Our buildings are here. So we do want to create something a bit more interesting. So I'm just gonna say this is not my highest level. I want to go down a little bit. And just not the antennas, I suppose. The other thing I noticed is that our buildings are quite same height, which somehow I haven't foreseen. Let's say that I want to copy these primitives, copy and transform. Let's say, how can I do that better? Copy to points, no, copy and transform. And I want to every stage to be, I don't know, like every floor to be 50 meters separated from each other. Yeah, and I want how many then? Until I hit the bottom. So I have 5 layers. I'm just gonna have to put a break. 1 second. Okay, so we have all these layers. So I guess now all we have to do is to run this in a loop. So I think we can create a number attribute that can drop in a for each. I guess we can say for each connected piece. That's like automatic. I didn't know this existed. That's pretty cool. Because it's gonna do that. Yeah, that's cool. And which means that plug this guy in here and this out. So it's gonna do the loop for each floor, but I think we can then change the but it's gonna look like I was gonna change the order here, but it's gonna look too chaotic, I would say, because I don't think that will you will just see all cars going through each other in every different layer, but I think this is just a bit more interesting. Some bigger areas, smaller areas. Okay, so we have our road network. I think that looks a bit too crowded. In order to fix that, I think we can just decrease the amount of points we pick. Let's go 8,000. And let's do the same for the end. I think 10,000 is gonna be a better option in the end. Yeah, I think this is still a lot. Or is it? Or just looking at every layer? Yeah, I think this is still a lot, so I'm gonna go 12. Let's go 12 here as well. Just selecting less and less points, pretty much. Okay, let's stick to this for now. So the other thing is basically you should probably look from the top view, and you never want one of these lines to cross so closely. Let's investigate one by one. So that's one layer of road network, and that's the lower layer, and that's the lower layer, vice versa, lower layer, lower layer. All right, so we have somehow elaborate traffic system at the moment. Well, I mean the road network. Obviously these are just going to be where the cars are going through. We're not going to see any roads visible. So what I want to create now after this is to create a polyframe, and I want to create my tangent name to be normal. That's how I'm going to align my cars, and then I want to create a scatter. So that's how many cars you want to travel, basically. But what we can do is I'm going to make sure that it's running only on one first, and that's somewhere, I guess this floor, somewhere middle. Okay, now let's scatter. So these are gonna be our starting points for our cars. So I want 1,200 cars, and then I want to rest these points so they're not on top of each other. Okay, which means I'm going to increase my relax iterations to 100, and then I'm gonna increase my radius. This is okay, so maybe it needs something 100, and then we don't have P scale at the moment, right? So this should rest them a bit better. I believe that should do the trick. Maybe more. Yeah, I think that's, let me see before and after. Okay, kind of relax them already, so they're not on top of each other. Now I'm going to create an attribute wrangle. And in this wrangle, we're gonna define our instance IDs to the amount of cars we have. Okay, so which means float. We're gonna create a random value, a random float called random val. Okay, and I want to create a ramp for this. So this ch ramp is the expression, the function. First one is the name of the ramp, which is a value in this case that we want, and then based on a random value based on a position. Okay, and okay, so that's what's gonna create. And then now I want to create, so that's, if we need to investigate, we can do like this f@, because we don't want to export it, so we don't need it. But if we want to see what it's doing, it's just gonna create a random value based on position that I can play with. We could bind this to like a height or anything, but that's just but I don't need to export this. I don't need more attributes to delete after. So right now it's just going to leave here, and it's just going to pass that value to the next command. And then I want to create a new ID called instance ID. ID equals, so I want my random val, okay, fit to the amount of cars I have, right? So I'm creating a fit function here. Sorry, that's how that works. This works like this. So fit random val. I'm having little Steam is sending me stuff, so please don't exit. Random val 0, 1, because that's what it does. And then I want to squeeze this to how many cars I had? 7, 8. So that's going to create an integer, semicolon at the end. I think, do I need? So it creates me an integer from 0 to 7, which is, I believe, exactly how many cars we had. If we go back, 0 to, this is 8 points, 0 to, yeah, okay, it's not sorted. Yes, 0 to 7, so 8 cars. Okay, so this needs to be 0 to 7. I think we have one extra. Let's go back there and then change our expression. 0 to 7. Okay, so there's gonna be a little hello warning here, which is because it's an implicit cast. It's like you did it, but you did. Yeah, I'm fixing it, but you're doing it wrong. So let's fix that, which means that because I'm creating a float and I'm declaring it as an integer, which is causing a problem. So then on the other side of my equation, I can say, hey, that's an integer. That should fix the error. Let's name this guy instance IDs. Instance ID creator, actually. So then I want to. Well, I did a relax. I want to do a 3D relax. Yes, that's what I was doing. I want to create a 3D relax, which is going to actually relax the points. So I don't want them to be all exactly on the same height. So I'm creating like a 2D point radius set to 2. So it's kind of like that's what it does basically. Gets the points together or not. And then as soon as they all start separating, which is at 2.7 in this scenario, but then I want, they're still on the same height. So what we need to do is to relax them in 3D space. And oh, I did too much. Come back. It was too much. Let's go 1, 5. I think that's slightly better. Okay, so as soon as I think that's kind of the value that everything is split a little bit better. It's not really doing a good job, to be fair. It's not the 3D split is not as much as I would like it to be, so maybe we need to, let's have a look from the side view. Maybe it's because it doesn't really need. Okay, you know what? I'm going to do the 3D part manually. So yeah, it's kind of like not working. So let's make sure that it's separated from top view. There's overlap, otherwise there'll be overlapping cars here. So let's give it as too much. Okay, maybe. It's not really doing a good job, is it? Okay, let's leave maybe max iterations at 10. I'll try to create something more reasonable. Okay, that's not bad. A little bit more. Okay, so it looks like most are split now. Let's push to see if it's gonna make a bit more difference. Yeah, maybe we have too many cars on one layer. Let's go 500 cars, or even 100. No, 500. Okay. I think now we can just use point jitter. To give them a bit more offset on height, I guess. Axis scale, let's go 0, 0. If you look from the side view, it should be already spreading. Okay, 20. Okay, so now everything is more spread out. Okay, and so now what I want to do is to create some attributes. Maybe we can start with the we can probably put a null here. Can actually we're actually ready to put this in a .NET right now. So out points. Okay, let me check the video length. Okay, still it's only 12 minutes. Okay, oh, it's because I had to stop the video. Okay, let me add this up and then I'll come back because I lost the total number of the video length. Okay, just